Hello again, this is Keith Davis at KLJ Instruments. Now that I have discussed the Squitter2M synchronous mode of operation in previous videos, I am ready to demonstrate the asynchronous mode of operation. As the table shows, the synchronous interference mode allowed for a single stationary target, while the asynchronous interference mode may have up to 250 stationary targets. Also, the method used to program the interference is different, which I will demonstrate shortly. But first I want to point out a few features that I didn't take time to cover in the previous videos. There are three ways to trigger the start of a scenario. We have been using the internal trigger. The scenario starts after the run button is pushed. When external is selected and the run button is pushed, the Squitter2M will proceed through its normal preparation and then pause to wait for the trigger. When 1 PPS is selected, the operation is similar. If the cable that is used to connect the RF out port to the UUT has a known loss, then that value may be entered as the cable loss. The Squitter2M will increase its output signal level by this amount. Latitude and longitude data may be entered as decimal values or degrees, minutes, and seconds by selecting the desired format from this menu. As we look at the asynchronous target setup menu, we can see two additions and a change from the synchronous target setup menu. The first addition is the target number. Each target has its own position information and squitter types. The second addition is the button to access the target enable-disable menu. The third item is the change from sync to async interference type. Asynchronous interference has a different programming philosophy which we will explore later. I will program two targets. Target 0 will have a Mode S address of 654321 and a flight ID of async0. The RF level is -50 dBm. Latitude is 38.881 degrees. And longitude is -94.819. And the altitude is 2,500 feet. And I will make the target airborne. Target 1 will have a Mode S address of 456789 and a flight ID of async1. The RF level will also be -50 dBm. I will offset target 1 from target 0 by -0.01 degrees in each direction. So the latitude is 38.871 degrees and the longitude is -94.829 degrees. The altitude is 3,000 feet. Target 1 will also be airborne. Now I want to set the length of the scenario by number of squitters instead of time. So I will move the slider up and enter 200 for the number of squitters. There's one more step I must take before I compile this scenario, and that is to enable these two targets. Now I can compile the scenario. I will save the GUI files as a2targets.csv and the scenario file as a2targets. I am now ready to run the scenario and look at the results from the radar cape receiver. I can see that both targets are received and each target is displayed with the Mode S address, flight ID, position, and altitude that I programmed. Next I will add random asynchronous interference to the scenario. I will load the GUI file with two targets as my starting point. Then I will go to the target setup menu. On the Target Setup menu, I will move the slider to Enable the interference, and then proceed to the Interference Setup menu. Now I have the Asynchronous Interference Setup menu open. Notice the differences between this menu and the Synchronous Interference menu. The first difference is that channels 1 through 5 are all enabled. The Squitter2M will automatically locate or allocate the interference between these channels. The RF frequency and average number of ACCRABS pulses is programmable as before, but the timing is not. The timing is assigned randomly by the Squitter2M. And finally, the RF level is programmed by assigning the transmission rate for each power level. The total ACCRABS for all power levels is 58,910. The total mode S short plus mode S long for all power levels is 10,460. I'll program a few RF levels and then compile the scenario. Now that I have compiled the scenario, I want to save the GUI information in a GUI file. And I want to save the compiled information with the same name. I will enter a brief description of this scenario in the text file. Now I must load up the new scenario files, select them, and then run the scenario. I hope you are able to see a random assortment of ACCRAB signals at -40 dBm, short mode S signals at -50 dBm, and long mode S signals at -60 dBm. This concludes the demonstration of the Squitter2M asynchronous interference mode of operation. The next video will explore the features of the wide area multilateration mode. Thank you for your interest in the Squitter2M ADSB signal generator.